So this is the beginning of exam 2. So this is our first video series, which will discuss intro to functions, function notation, and systems of linear equations. So you'll see that what we'll start with is just that discussion of relations and functions, domain and range. We'll talk about looking at graphs and determining if it is a function, and then we'll talk about function notation. So first off, let's talk about what is a relation. And a relation is simply just a set of ordered pairs. So we're dealing with that relationship between x and y, and we can look at different contexts where we have an independent variable and a dependent variable. For instance, examples of relation would just be the ordered pairs, so -2, 5, -1, 4, 0, 0, 1, 4, and 2, 5. So these would be examples of relations. We could also look at context. So we could say the year 2000, comma, and it was $1.56. 2005 was $2.34. 2010, $2.84. And then 2015 as our X, 339 as our Y. The gas price per gallon was dependent on what year we were discussing. Another context would be the amount of in the paycheck in dollars is dependent on the number of hours you work. So the ordered pair for 50, 1080, 20, 160, and 40, 320. Those would all be ordered pairs and examples of relations in context. Then you've got special types of relations, which would be called a function. Function is a relation in which a distinct value of x, or we could say for every x, there is a distinct value of y. And so for functions, we would have to say the x values cannot repeat. The y values, however, can repeat when we look at determining if something's a function or not. To begin, let's look at, we'll come back to that, but we're going to look at the idea of domain and range. Domain is your x values, your input, and your range would be your y values or your output. So your domain and range here, we could say D colon and then my set, and I would go from smallest number to largest, so -2, 0, 2, 4 would be my domain. So I'm listing my x values to represent my domain. My range would be in the set of just -3. So we can have the y values repeat, but I would only write it one time. And let me back up to this screen here. So if I were going to state my domain, notice the x values was only once, but the range was from -4, -2, -1 to 5. This is an example where you see the x values are repeating. This would not be a function. But when you look at this second one here, the x values do not repeat, the y values repeat, and that's okay. This would be a function because for every x value, there is an exactly one y value. Here, for every x, there is a different y. And so this one-to-many is not going to work, and this would not be a function. Domain here, we would say 3, 4, 5, 7. And the range would be 1, 2, 6, and 9. Notice there's no repetition in the x values here, so this would definitely be a function. Now, if you might have the ordered pairs written in a set notation and you want to figure out the domain and the range, so you're just looking at the x values. So I see 1, 1, 0, 2, 2. I do see repetition of the x values here and here. So this would not be a function, but if I was listing the domain, it would be it'd be 0, 1, and 2 from numerical order. And then the range, you would see from -4 to -1 to 0, 1 to 4. So I see 1, 2, 3, 4, 5 ordered pairs, and I see 5 range values down here, but I only see 3 on the x, or the domain. That means that we had repetition with the x values. And that would disqualify it from being a function. Second group, I'm looking at the domain, and I see 2, 3, 4, 5, 6. I do not see any repetition, so 2, 3, 4, 5, 6. This would be a function. The range would be 5, 7, 9, 11, 13. So we would say, yes, this is a function. For every x value, there's exactly one and distinct y value. So again, just reiterating that definition of a function. Now we look at a table, and I just want to determine yes or no, and I'd like for you to be able to tell me why and how you know. So is this a function? So you're checking your x values, 1, 2, 3, 4, 5, 6. There is, this would be yes, no, repeating x values. So this is definitely a function because there's no repeating x values. So we look here, 1, 2, 1, 3, 4, 5. I see repetition here and here. So this is a no. It's not a function because the x values repeat. This is a mapping diagram. So if I were to look at the ordered pairs, this would be 0, -2. So see, 0 is mapped to -2, but 0 is also mapped to 1. 1 is mapped to 2. 2 is mapped to 1. And 3 is mapped to 4. So the error lies right over here where we've got repetition with our 0, and you see that 0 maps to -2 and 1. So for every x value, there's exactly one y value. Well, here we're saying there's one x value, but then we have two y values. And that would be similar to if you were typing a letter on your keyboard, and you would expect to start, when you start typing your a letter or your name, you would expect for that button to represent a letter. So if I'm typing an M to start my first name, I would expect an M, not an M and a W to pop up. So that's a consideration. That's the idea of that one-to-one function. Now we can look at graphs and determine if they're functions. And so what we want to use with graphs is a tool called the vertical line test. Now, we're going to use a vertical line because the vertical line will give us an idea of how many times the line crosses through a graph. And if it crosses more than once, then that means that we have the same x value and different y values. For instance, here, if I draw the line, the vertical line here, I only see it cross that graph one time. So the one on the left is a function. This is a linear graph. This would be a function. If I use the vertical line test here, I'll see that it crosses this piecewise function in two places. So this is not a function, because when x, let's say, is 3, you have a y value of 4 and a y value of negative 4. So that would disqualify it from fitting the definition of a function. Let's do the same thing with the circle. We can test whether the circle is going to be a function. And we're going to see we hit here or we hit here in two spots. So this is not a function. And again, testing at different spots on this graph. This would not be a function. Another graph you could test, vertical line test there or here, and you would see that it crosses at one time. So this would be a function. Same here, I could test just the multiple places. Wherever I test, you can just see that wherever I test, it only hits the graph one time. So we know that this is a function as well. Now let's switch gears and let's talk about function notation. And then we want to look at how we can evaluate a function, and then how we can write different equations in function notation. So function notation is simply another way to write the y equal. So notice you've got your y equals mx plus b, but we wrote it, instead of y equals mx plus b, we wrote it as f of x equals mx plus b. Well, that's, like I said, f of x. That's how we say that term, f of x. F is the function name, x is the name of the input, and f of x is the function value when we have something for the input. So f of x, think of it as it's the output of the function whenever we have an input that is x. So when we say f of 3, it just means that whatever the expression is, let's say x plus 5, I'm substituting a 3 for x. And now I can evaluate and say that f of 3 is 8. All that means is when x is 3, y is 8. And then we'll commonly see it as f of x And you can see the difference in writing it as y equal and writing it as f of x. Now we can use different function notations. We can call it c of t. We could call it d of m. We could call it f of a. Lots of different ways. But the function is the first letter. We could call the c cost. We could call the d distance. We could call the f for anything. Could be food amount. And the inputs all represent whatever that input could be. So t could be time, and m could be in minutes, and a could represent something. It's totally just depends on the context of the situation. When we talk about evaluating a function, we want to think about what that evaluate piece means. And it really just means that we're going to substitute. We're going to substitute an input for x, and we're going to determine the value of that. And how are we going to do that? By your order of operations. So if I have, for instance, with this example, if I have f of x equals 5x, and I want to say, well, what is f of 4? Well, you're just substituting 4 in for x. So f of 4 is 20. So what you would see is 4 comma 20 is your result. And if I had f of t is equal to t plus 2, and let's see, so we're going to use 4 again. So f of 4 is equal to 4 plus 2. So f of 4 is equal to 6. So 4 comma 6. That would just mean when the x is 4, you have a y value of 6. And then a squared plus 3a plus 1. A squared plus 3a plus 1. And if we notice that was f of a, so I can put the function notation on the right side if I need to. And if I use 4, if I use f of 4, then that would be 4 squared plus 3 times 4 plus 1. So you're just evaluating, you're just substituting wherever you see an input or an x value of 4, we substituted 4. And then we just computed 4 squared is 16, 3 times 4 is 12, plus 1, so everything's left to right, so that'd be 28 plus 1, or 29. So when x is 4, y was 29. So these last three are just examples of how you would evaluate. So h of r, I want to know h of negative 5. So wherever I see r in the formula, I'm going to substitute. So wherever I see r, I'm going to substitute negative 5. And then I just need to compute it. So this would be negative 25ths plus 11. Negative 25ths is negative 4 plus 11. And so that's going to be 7. So h of negative 5. The function h at an input of negative 5 has an output of 7. So negative 5, 7 would be the ordered pair or the solution to this when we evaluate it. So we say with f of x, w of t is what we would say here. So when w is negative 7, we will just substitute everywhere we see a t with the negative 7. So w of negative 7 is positive 14 plus 1. So we would have w of negative 7 is equal to 15, so negative 7, 15 would be the ordered pair. And then finally, h of n gives us this expression. So we want to find h of 4. We're just going to substitute, and we want to be careful that we're doing the correct order of operations. So we want to start with here when we're dealing with exponents. So that'd be negative 2. And 4 squared is 16. It's not 4 times 2. It's 4 times 4, which would be 16. And so now that's negative 32 plus 4, so that would be negative 28. So when x is 4, y is negative 28. So those are just some examples of working backwards now and review of how you would evaluate an expression using function notation, which we said function notation is just substituting the x values in and then determining the y values using the order of operations. And then we looked at what would constitute a function when we would use the vertical line test. And if it only hits once on the graph, then we know it's a function. If it actually hit twice on the vertical line test, then we know it would not be a function. And then we also looked at if the x values repeat, we knew it wouldn't be a function, but if the x values did not repeat, that it would be a function. We talked about finding domain and range from ordered pairs, domain and range from tables. Remember, the domain would be the x values and the range would be the y values. And that a relation is a set of ordered pairs, independent variable and dependent variable. So that concludes the first video. So this will be part 1, and there'll be 3 parts of our first lesson in exam 2, Intro to Functions, Function Notation, and Linear Systems.